last question, question 22. We have a table below contains 5 statements that refer to isotopes and some radium isotopes. I'm not quite sure what they mean by that, but never mind. And it's a tick box to identify the appropriate isotope. The first one has been completed for us, so I'll put that in there. Right, so next one, the one with the most neutrons. The one with the most neutrons is going to be the... I'll do a different colour for this. It is going to be this one, because it's got the biggest mass number. Remember, it's all just isotopes, so the proton number's the same, so that's definitely going to be over there. The one with the largest specific charge, well, they've all got the same charge in the nucleus because they've all got the same number of protons. So we're looking for something with the smallest mass, which of course is going to be this one because it's 223. One which may decay by beta minus decay to perform 22589. Well, beta minus decay doesn't change the mass number, so it's got to be 225. And of course the bottom one's gone up by 1, that's fine. And one which decays by alpha decay to 22086. So if it's decayed by alpha decay, then it must have a starting atomic mass of 224, because it's 224 less 4 to get to 220, and a proton number of 88, which gives us that one. Right, so they're all done. Part B. Part 1. An atom of one of the radium isotopes in the table is ionised so that it has a charge of 3.2 times 10 to the minus 19. Well, 3.2 times 10 to the minus 19, it should be obvious that that's actually just 2 electrons. Now it's plus 3.2, so it must have lost 2 electrons for this to happen. Right, part 2. Let's give ourselves some room first. Part 2. Specific charge of the ion formed is 8.57 times 10 to the power 5 coulombs per kilogram. Deduce which isotope the table has been ionised. So to do this, I'm going to work out the number of nucleons. Because if I get the number of nucleons, I'll be able to match it up to this top row here and identify which isotope it is. Remember, specific charge is the Q over M ratio. So if I want to work out, first of all, the mass, I can say the mass is Q over specific charge. And if I want the nucleon number, which is going to be our atomic mass, then I'm going to have to take its mass, which is what we said earlier, Q over SC, and divide that all by 1.6, I want to say 6 in this question, 1.66 times 10 to the minus 27. So now it's just a case of plugging in our numbers here. Q is the charge on the nucleus, that's going to be, charge on the ion, which is going to be 3.2 times 10 to the power minus 19. It's not the charge on the nucleus, the question asks for the ion here. And specific charge, we're told that 8.57 times 10 to the power 5, and we've got the number down there. Plug that all in, and that will give you a number which is close, very close to 225. So clearly it must be this isotope here, which has been ionised. And that, I believe, is it.